Good day, everyone. So my name is Dorothy Wing Alfranca, 39, and I'm going to discuss about river engineering content. So this is the contents of my report. So the first one is the river closure. The second is the canal headworks. The third is the bridge score. The fourth is the navigation. So before we proceed to the first content, so let us first have a quick review of what river engineering. The river engineer is a branch of civil engineering dealing with the design and construction of various structures to improve and or restore rivers for both human and environmental needs. And then with utilization of modern day, state-of-the-art technologies in data collection and modeling, river engineering can improve navigation, reduce dredging, and enhance or create new habitat. Then river engineering involves the management of sediment and the control of erosion. Then sedimentation is one of mankind's largest problems. And sedimentation can choke rivers, clog water intakes for municipal water supply, halt or hinder the transportation of commodities via navigation, and destroy backwaters and wetlands. And also erosion can endanger private property and infrastructure, cause major river cutoffs, and increase sedimentation. So first is the river closure. So what is river closure? So river closure means that the river is closed and diverted and the cofferdam is sufficiently sealed to allow continuous excavation of it. So here in the picture you can see that is an example of river closure. So the purpose of the river closure is diverted through a tunnel and subsequently discharged further downstream to the same river or into a different river basin. Then it is stored temporarily in a reservoir and subsequently discharged in a controlled manner by means of spillway, powerhouse, or irrigation net. Then it follows from the above that river closures are required. First is to close one or more channels of a river as part of river control works or to create temporary river diversions by means of cofferdams to establish a safe and dry environment for the construction of the permanent reservoir dam and its ancillary works. So in figure 7, consider the number 1 is the diversion dam, the second one is the planned sheet piling for final closure or the cofferdams, and the third one is the rockfill dam. And the second is as part of the closure of diversion passages through an unfinished reservoir dam at the same time of its completion or as part of the separation diversion works. So this is generally called as closure of diversion works. And then to establish diversion dams, by set up of the water level against the dam will divert water in all. Then diversion may be to an irrigation intake or to a transbasin canal or tunnel. Such a diversion dam can be overtopped. And lastly is to create a more or less permanently overtopped pier without gates which has a function for a river navigation and or run of river hydropower generation. Then next, uh, the second one, which is the canal headworks. So what is canal headworks? So canal headworks is any hydraulic structure or works constructed across river and supplies water to the off-taking canal is called the canal headworks. So there in the picture, that is an example of canal works. Then next is the purpose of canal headworks. So the first is the purpose of it is it raises water level in the river. Next is it regulates supply of water into the canal. The third is it controls the entry of silt into the canal. And fourth is it provides some storage for a short period. Then the fifth one is it reduces the fluctuations in the level of supply in a river. So canal headworks has two types. So first is a diversion headworks. So here is the weir or barrage is constructed across a perennial river to raise water level and then divert the required quantity. So the purpose of diversion headworks is it raises the water level. So diversion headworks has two types, so which is the temporary diversion headworks. So this consists of a bond construction across river to raise the water level in the river and will be damaged by flood. So temporary na siya because dali na siya makuba, especially madamage siya sa floods. The next is the permanent diversion headwork. So it consists of a permanent structure such as a weir or barrage constructed across river to raise water level in the river. So site selection for diversion headwork. So the first one is river section at the site should be narrow and well defined. And the second is should have a large commanded area. And then the site should be that the weir or the barrage can be aligned at right angles to the direction of flow in the river. Then good foundation should be available at the site. Then the site should be easily accessible by road or by rail. And the overall cost of the project should be minimum. Then the second type of canal headworks is storage headworks. So dam is constructed across a river valley to form storage reservoir and divert the required quantity. So here figure 2, that is an example of a storage headwork. So location of canal headworks. So the first location is the rocky stage. So in this stage, river is in hills, the bed slope and velocities are high, and it is generally not suitable for the location of a diversion headworks. And it has advantages and disadvantages. So let us first discuss the advantages. So the advantages is a sound rocky formation is usually available at the site. Then due to high velocities of flow, no silting problem. Then high heads are available for hydroelectric work. And the disadvantage is that the land in the hill area is not suitable for agriculture. And then the discharge in the river is low because of small catchment. Then the second stage is the boulder stage. So in this stage, the bed and banks of the river are composed of boulders and gravels. And the advantages is the length of the weir um, is generally shorter in boulder stage than the construction materials such as stone, aggregate, sand, gravel are locally available. And the disadvantages is that seepage losses are high and the demand of irrigation water is low because the land is not fertile. The third is the through stage or the alluvial stage. So in this stage, the cross section of river is made up of alluvial sand and silt. The bed slope and velocities are small, then the advantages is that demand of irrigation water is high, and seepage losses are less in the canal. Then the water contains silt which has mineral value. And the disadvantages is that the construction material is usually not available locally. And then the cost of headworks is usually more due to poor foundation. And then the last stage is the delta stage. So the river passes onto the delta stage as it approaches the ocean. And then the bed slope and velocity are reduced so much that it is unable to carry its sediments load. And the third one is it drops down the sediments and gets divided into the channels on either side of the deposit, resulting in the formation of a delta. And Delta stage is not suitable for location of a diversion headworks because the river section is excessively wide. So the third one is the bridge scar. So what is bridge scar? So bridge scar is the removal of sediments such as sand and gravel from around bridge abutments or piers. Scar caused by swiftly moving water can scoop out scar holes, compromising the integrity of a structure. So, in the United States, bridge scar is one of the three main causes of bridge failure, the others being collision and overloading. It has been estimated that 60% of all bridges failures result from scar and other hydraulic-related causes. It is the most common cause of a highway bridge failure in the United States, where 46 of 86 major bridges failure resulted from scar near piers from 1961 to 1976. So, this is an example of a bridge scar. So, areas affected by it. The water normally flows faster around piers and abutments, making them susceptible to local scar. At bridge openings, contraction scar can occur when water accelerates as it flows through an opening that is narrower than the channel upstream from the bridge. And degradation scar occurs both upstream and downstream from a bridge over large areas. So over long periods of time, this can result in lowering of the stream bed. Then the causes of it is that stream channel instability resulting in river erosion and changing angle of attack can contribute to bridge scar. Debris can also have substantial impact on bridge scar in several ways. Then a buildup of material can reduce the size of the waterway under a bridge, causing contraction scar in the channel. And a build-up debris on the abutment can increase the obstruction area and increase local scar. Debris can deflect the water flow, changing the angle of attack, increasing local scar. And the debris might also shift the entire channel around the bridge, causing increased water flow and scar in another location. And the second one is the most frequently encountered bridge scar problems usually involve loose alluvial material that can be easily eroded. However, one should not assume that total scar in cohesive or cemented soils will not be as large as in non-cohesive soils. The scar simply takes longer to develop. The next is the fourth content, which is the navigation waterways. So the navigation waterways is previously discussed by the previous reporter, so we will just have a quick review of it. So the introduction is the waterway is any navigable body of water, the natural as well as cheaper means of transport. The navigation channels can be in rivers or in coastal areas. Then total waterways length in worldwide is about 2,293,412 kilometers. Then over 90% of the world's trade is carried by the sea. So this is an example of a navigation waterways. So inland waterways value. So over 90% of the world's trade is carried through waterways. Then the key element of state and local government economic development and job creation efforts. And then the essential in maintaining economic competitiveness and national security. And it provides major bulk commodities such as petroleum and products, coal and lignite, sand, gravel, stones, chemicals, grain, seed, iron and steel, logs and lumber, clay and glass and concrete, non-metallic minerals, and many more. And also, waterways has constraints. So the first one is slow movement and large areas are not traversed by commercially navigable streams. and it is inadequate dredging and shortage of berthing facilities. And when the tariffs regulated by the government are insufficient. And then the condition of piers, jetties, and other infrastructure is poor. So that is an example of constraints of waterways. So that's all. Thank you for listening and stay safe, everyone. Bye. Bye.